Okay, this should be fairly quick. Beer's law, this is an equation on your equation sheet, and it's that the absorbance is equal to EBC. Okay, so you're going to record the absorbance with your spectrophotometer. Okay, so that's where you'll get that. The E is the molar absorptivity. It's really, it's specific to the chemical. So different chemicals, you saw the peaks when we did the food coloring. Sometimes the peak was like this, and sometimes the peak was higher. Okay, so some things just absorb better than others. So it's specific to the chemical itself. B is the path length. And then C is the molar concentration. Or actually, it's just concentration, really. Because all of this stuff is proportional to itself, to each other. So if we took our equation these two terms, whenever we're doing a lab, these two terms are going to be the same number. So this is just a constant. That's some constant. And so what this says is the absorption is directly proportional to the concentration. And so what you're going to do is you're going to get 5 different concentrations, and you're going to measure the absorbance. And when you do that, you're going to get a straight line, and you're going to get what's called a calibration curve. So we just go, we get the straight line for there, and then we get the equation of the line. Okay, so this is just a line, so it's going to follow y equals mx plus b. M, in this case, is this constant. Because if you think about it, what is y? Y is your absorbance. So if we took this equation, in our experiment, we graphed y we graphed absorbance on the y-axis. So we have that our absorbance, which is our y, is equal to m. So m being that E and B together, so that's all together, that's m. And then on the x-axis, we have concentration. And our y-intercept is usually 0. It's going to be really close to 0. So you generally don't have to worry about that. It wouldn't be 0 if you forgot to put the water blank in there. And remember the water? Okay, that has some absorbance in itself. So this absorbs light in itself. And so when you use the blank, when you put the blank cuvette into the spectrophotometer, what you're doing is you are subtracting out that amount. Okay, and that makes our graph start at 0. Okay, so how are we going to use this? So here's the information we know after making our calibration curve with our 5 known concentrations. We know the equation of the line, and we have the graph. So there's a couple ways we could use this. One, let's say we put an unknown sample into, so we have our unknown sample, we pass the light through it, and it records an absorbance. Well, we could say, okay, that's the absorbance. There's the concentration. So that's one way we could do it. So let's say that we were given an absorbance of 0.75, we could then find out the concentration, or we could put it into the equation because we have absorbance equals, remember EB, that's one number now, it's our slope, that's our slope, M, times the concentration. So we could put this 0.75 in here, and we know the slope from the equation of the line, and then we can solve for the concentration. So there's two different ways we could do it. We could read it from the graph like this, or we could plug it into the equation like this, and that will give us the concentration of our unknown.